Hello, welcome back. And for those who might have joined just now or just come to see this particular lesson, my name is Osale Mahana. I am a teacher of mathematics and I've taught A-level maths for a long time. And I'm just using my knowledge and experience to share with you some notes and examples on various aspects of A-level pure maths so that it helps you revise. Okay, so let's get on with it. Anytime I start this particular topic, I'm in a dilemma. What's the dilemma? I'll tell you what it is. See, I have to now start e power x. And you know, those who are in year 13, by now you'll have learned that when you differentiate e power x, you get e power x. Or those who are doing further maths, by now you know it. And those in year 12, you'll learn it next year. The question is, do I have to show you why e power x derivative is e power x, or do we assume it? Again, a dilemma. But every year, my line of thought is, if you're doing further maths, yes, I'll show you. If you're not doing further maths, we'll assume it. Having said that, I have ended up for the past 40 years when I taught the A-level maths, the British A-level maths, or the Kenyan A-level maths followed by British A-level maths. I've always proved this. Of course, way back in India, of course, they didn't have those days derivative of e power x at A-level, it was at university. Okay, so I will do it. So in other words, we're now doing exponential and logarithmic functions. Of course, I have already done logarithms, so I'm not going to go over logarithms again. I'm talking of now base e. In other words, y is d by dx of e power x equal to e power x. That's the question I want to answer during this particular lesson. To understand this, I need the definition. Remember, f dash of x is limit h tending to 0, f of x plus h minus f of x over h. I need that. I also need binomial theorem. 1 plus x power n is 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cube plus etc. And then, of course, this is for small x. I need those two. So where's the link between that and this? Very interesting, as you will learn. So I'll pose a different question, not a question, problem. Find a constant a such that if f of x equal to a power x, then f dash of x is also a power x. My job is to find the constant a, and the constant a is going to be e, which you have learnt. Okay, so let's start. F of x is a power x. What is f of x plus h? Is a power x plus h, correct? So what is f of x plus h minus f of x? Will be a power x plus h minus a power x. Please, you can't cancel a power x. So can I remove this as a power x times a power h minus 1? My job is to find a. Yeah. Now, f dash of x is limit h tending to 0, f of a plus h minus f of a whole over, f of x plus h minus f of x over h. Yeah. Since h is small, can I say f dash of x is approximately equal to f of x plus h minus f of x over h, and then later on I'll take limit h tending to 0 to make it exactly equal to, yeah? But you know f dash of x is a power x, approximately equal to a power x. Look, this I have found out here, a power h minus 1 over h. My job is to find a, so I can cancel that a power x. If I simplify this, so I don't need this anymore. Of course, I will take limits, which I will do later. So if I can simplify that, can I say 1 is approximately equal to a power h minus 1 over h, which becomes a power h minus 1 is approximately equal to h. So a power h is approximately equal to 1 plus h. So a is approximately equal to 1 plus h whole power 1 over h. Oh, too many h's. Nothing wrong. This, remember, h is small, so I can expand using this formula. Alright, let's do this. So if I use it, I'm trying to use 1 plus x power n. 1 plus x power n. In place of x, you have h. In place of n, you have 1 over h. So a is approximately equal to 1 plus n times x plus n times n minus 1 over 2 factorial times x squared plus n times n minus 1 times n minus 2 over 3 factorial h cube plus etc. 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 to infinity. So far so good? Very good. So a is approximately equal to 1 plus 1. Look, I could use 1 over 1 factorial. For pattern's sake, I am writing. What I'll do is, I got an h squared, yeah? I'll cancel 1 h and open the brackets. What do I get? I get 1 minus h over 2 factorial. Plus here, I cancel 1, I get an h squared, right? What I'll do is, this h squared, I'll bring a h here and a h there instead of a h squared. What do I get? H times 1 over h minus 1 gives you 1 minus h. H times 1 over h minus 2 gives you 1 minus 2h over 3 factorial. If I want to now pattern 1 minus h, 1 minus 2h, 1 minus 3h over 4 factorial h cube, no h cube, plus etc. to infinity. This is approximate value of a. What is the exact value of a? So a is limit h tending to 0 of all that bit. I don't want to write the whole thing again. That means, remember, theoretically h is never 0, but it is so small that we can consider it to be 0. So this h becomes 0, that h becomes 0, that h becomes 0, that h becomes 0, that h becomes 0. So every h throughout will become 0. So a is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, etc., etc., etc. That is the number E, which is 2.7182 something. That is how E is the only number in the whole field of pure mathematics. When you differentiate e power x, you get e power x. Please don't think derivative of a power x. Standard answer is a power x. Or a cleverer answer, x a power x minus 1. No. You cannot differentiate a power x. You can differentiate e power x, but e power x doesn't give you x e power x minus 1. Remember, to use x power n formula, the power n must be a constant and the base x must be a variable. So when you say e power x, the base is a constant, the power is a variable. So e power x is the only number in your life. As a math student, when you differentiate, you get e power x. Is that clear now? So therefore, that is how you find e. So now you can add a list, go back to the list which you have prepared and add on to it. As I said, if you think it's not worth it, you don't have to remember, but at least my conscience is clear that I have shown you why derivative of e power x is e power x. So in your formula sheet, add y and dy by dx. So if y is e power x, dy by dx is e power x. And that's the only number on this earth. Alright. Then let's see. Suppose I have y is ln x. What is dy by dx? So. Yes. Yeah, 1 over x. Somebody is telling me there it's 1 over x. Correct? But why? How do you get 1 over x? That's what I'm trying to show you. I can't differentiate because I don't know the formula. So from here, do you agree log x to base e is y? So x equal to e power y. Look, y equal to e power x, you differentiate with respect to x. X equal to e power y, can't I differentiate with respect to y? So dx by dy is e power y. So what is dy by dx? 1 over e power y. But what is e power y? X. That's how you get derivative of ln x, as some of my students say, or log x to base e, or ln x is 1 over x. Okay. Then, okay, sir, but no, you don't always get e power x. Find dy by dx when y equal to a power x, 2 power x. Or sometimes they say using a power x equal to e power x ln a, show that d by dx of a power x equal to a power x ln a. This is a standard A-level question. I've seen it so many times. So remember, if it is not e, you have to multiply by 4. Therefore, the answer for this would be ln 2 times 2 power x. I need to prove this. So let's call y equal to a power x. This proof, please understand, you need to know this proof. So y is equal to e power x ln a. Find dy by dx. Remember, ln a is a constant because a is a constant. Onion rule. If you don't like onion rule, I'll show you. So y is equal to e power u equal to ln a times x. dy by du is e power u, du by dx is ln a. So dy by dx is equal to e power u ln a. But what is e power u? Y. Y ln a. But what is y? A power x. So a power x ln a. That is how you prove it. But I don't like those u and v and w and x and y and z. I taught you onion rule. How do you evaluate this? Find x. Find e power x. Suppose x equal to 2. Find e power x. Can I write this as e power x whole power ln a? Okay. Or this one, see, onion rule. So first you find x ln a, and then e power x, right? So when you're differentiating e power anything, it gives me e power the same thing. That takes care of the e. And then I'm differentiating x ln a, I get ln a, which is a power x ln a. So that's look, in case you're not asked to prove, you can use that as a standard result. But in 99% of the cases, they ask you to prove. So therefore, if y is 2 power x, dy by dx will be 2 power x ln x. And of course, you know, ln 2. And you know that e power x and ln x are inverses of each other. They're reflections of each other in the line y equal to x. Yeah. So what I would suggest is add those things to your formula sheet. Apart from this, I think the only one, I've already given you parametric equations. Yeah. The only thing that will come up will be perhaps implicit differentiation. Apart from that, at A level, the formulae for A level are almost over when it comes to differentiation. So in the next lesson, I will take examples on applying these formulae. Of course, when you want to apply this, we're going back to all the other remaining lists. I could do ln cos 2x plus 3 or ln cos cube x plus 1. So we're going back to all the basic differentiation as well, and tangents and normals and maximum and minimum. Okay, we will talk about it in the next couple of lessons. See you later. Have a nice day. Ooh. Thank you very much. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.